what it will give actually?
So actually we need to get the data like this.
No, what actually the data consists of? Log converter.
So initially we are logged by DLF files. So binary logging files. So the binary logging file we are able to see the help of any one of the testing tools. Okay, sir. So instead of that, we can see the same logging file with the help of ASCII values and then comma separated values, CSV file. So first we did the ASCII values, so we got the proper output, which means we can see the proper. So one was the CSV file, so comma separated values we can see in the Excel files. So that I am checking the basics and issues.
That is okay, sir. Actually, what it consists of? What type of data it consists of? What is the use of?
Saturday I took the class for the analysis and then logging, stop logging. Which means what are the analysis we did last 1 hour, what last 8 hours, what we did, what all the values will be stored there. So that values we are going to replay for some of the testing purposes or any kind of the purposes. So once we converted this CSV file, which will get the data like that. So ID number, so can frame ID, can data, so can DLCs, can data, can DLC. So what are the values are for the each and every values? Okay. So I think I lost some data from my BLF file. You are stored nearly 4 BLF files on yesterday also, correct? So you just check with that BLF file to CSV file. We are already having some logging files. Okay, sir. Yes, because I am just having that some empty file. My BLF files are having empty values, so that I am not getting that exact output. So my BLF values are in 0 KB, so which means it is not having any data, so that I am not able to convert it. So after the conversion, we will get the output like that only. Yes. So what is the timestamp? What is the CAN channel data? What is the data frame? Which means data frame is nothing but a CAN ID. So and then what is that transmission TX or RX? What is the DLC? What is the DLC values are from 1 byte to 8 byte? So byte 1, byte 2, byte 3 like that. Okay. So it is the frame ID for the J90 that may not have CAN protocol. I don't have any logging value of CAN right now, so that I am not getting the exact value. Or else we just log the same concept. So go for start bus logging. After you can transfer. So now we got the message. So for our timing TCU, we just transmitted TCU only. So we got the TCU vehicle speed. So on the TC transmission gear issue, we are not changing any values. So after we just see. Here you can see the values are changed for the TCU. Okay, so vehicle speed. So on the previous way, I don't have any data, so that I am getting the any values. So now just now we log the same values. So BLF file are converted to the comma separated values. So as of it is also one kind of analysis purpose. We don't need any kind of tool. We just have the CSV file, so you can see in the Excel source or any notepad source, so you can enter in these values. So that. Okay. Okay. Okay, so this is the log converter. So here we mostly using only CSV and DAC file. If people know about the math file, means you can connect to the math also, and then they are giving two options, PCAP. So the PCAP is nothing but it is using for AutoSer purposes. So whenever we are working with AutoSer, so on that time we are using the PCAP files. Okay. So shall we go to RBS? Yes. So analysis tab, we have covered all the points like measurement columns, measurement setup messages. The real time command nothing but we have directly access into the graphical window. Okay, so without graphical window we are not able to access the real time command. We need to add the signals and graphics window, place some cursor, afterwards we can access the real time command. So statistics, database stages, logging, all the topics we covered. Is there any doubts in the log converter? Yes, sir.
Real time comment is disabled.
Real time? Okay. So the next one is the simulation part. So from the tab left side onwards, the fourth one. So simulation tab, you can open it. The simulation we are going to work for this all environment. In this remaining simulation, we are going to work for CAN simulation. So first we need to complete the CAN RPS. After we will move this kind of environments. Okay. So just to open this CAN RPS simulation. So please all check your database are uploaded or not. Okay. So initially I am not uploaded, later only I uploaded. So you can check your database are uploaded or not in your database. Okay. So in this rest of the simulation work is nothing but without simulation we are going to without ECUs we are going to simulate all the values. So that is called as the rest bus simulation. So what are the ECUs will transmit and receive the real time answer. The same thing we are going to do here without the real time ECU. We are just simulating the values. We are just simulating the ECU. We are just simulating TX message and then RX messages. Okay. So for this we are having the first initial step is we need to turn on the simulation, which means this analysis stop. We are having that simulation start and then stop. We just start the simulation. After only this RPS will be able to work. So in this RPS column, the top left we are having an arrow mark and then one box shape. The arrow mark symbol is for the remaining bus stop. So box column is for remaining bus stop. So this is nothing but whenever we can stop this, we are able to simulate this kind of the ECU. What are the ECUs we have created in our database? What are the values we have enrolled in our database? That is the values we are going to work here. So here this factor parts are majorly working here. So in our signal creation of database signal creation, you mentioned some factor values. So factor as a 1, factor as a 0.7, 0.6 like that you mentioned. So that is the value we are majorly playing. Okay. So first we can start the simulation. So whenever we need, so first we can start the simulation. So afterwards we can just drop on this. It is giving our network. Afterwards it is showing what are the nodes we have created in the database. So first you have to start the simulation. After start the RPS simulation. Third step you can activate the network. Third step you need to activate network. So without activation of network, the nodes will not work. So for example, if I stop this, now we are just turn on the TCU node means after the values you transmitted, it will not transmit anywhere. So we need to activate database also. So after database, you can activate any one of the node. For example, here I mentioned TCU, transmission control unit. Okay, so just to drop from the TCU only. So it is showing the transmission message. So it is showing transmission message TC underscore 1. Just drop on that message also, it's showing what are signals it is carrying. Okay. So first step, don't forget to turn on the simulation. Second step, turn on the RPS simulation. Third one, you can just drop on this channel values, you get them CAN DBC. CAN DBC means nothing but the network. Okay, we need to activate the network. Afterwards, what are the nodes we need to open? Okay. So just activate the network, afterwards activating the node, afterwards activating the message. Okay. So once you activate this message means you will get the trace output. So here it is showing the trace window. I totally deleted the transmission. So we don't need to using the transmission window here. We are just working on this vegetable simulation only. So what are the work we can do here, which what are values we are transmitting? That is only we need to see here without the help of any transmission window. Okay. So for example, now I turn off this messages means the message will get the deactivations. So now the message will not transmit here. So this is the concept of like real-time message. Real-time is you transmitting the values like that we can assume now. Okay. So for example, now I transmit here automatic transfer. If we can turn off this, we are which means I just turn off the network. But the nodes are activated and then the messages are activated, but we are not activating the network, means you are not able to receive any messages. Okay, so that is the reason I mentioned first you can start the simulation, afterwards you can start the RB simulation, afterwards you can definitely start some network. Okay, after activation of network, what are the nodes are activated here? So what are the nodes you have activated in this tree we can see. So you just double click this tree means the node will be deactivated. Okay, you just again double click means node will get the activations. Okay. Okay. So this is the transmission of messages from the rest of the simulation. Now we are just transmitting the messages, we are not setting any values for the signals. So our concept is we need to give the values for the signals. So here we are having that the values of data last column. This last data field column you have it in your RBS. Okay, so in each signal we are having some values of 0, 0, some 1, 0. Like that. What are the values we mentioned in our database? The values, initial values will be showing in our database. For example, now I can view this value as 100 means the same 100 is transmitted in our output source also. Now let's see the trace. We can see the trace window. So, but our major concept is it is a transmitter. What is the transmitting? It is showing. But we need to check on the receiver. That is the main part in our RPS. So for this vehicle I mentioned receiver as IC. So we can just go to IC. So IC control node. So just open it and the last one we are having that message of vehicle speed. So here also change it. So now this CC is also able to receive the message. Here also receive, this CC is also able to receive. But here we are not able to changing any values as the receiver side. For example, I can change the values of 200. When say give the enter means only the value will be taken, I can give the enter, it is taking the values as only 100. Because what's the transmitter giving the value, that is the value able to take the receiver. The receiver not able to changing the values. Okay.
But we can't take this right in ICE. If we go and click PC, but then we can't make it as like highlight.
Tick mark. You can just give this box active column. The active checkbox is there.
So if you give B200, does it consider as a range?
Which one? 100.
Range is B200.
100 means the 200 means range only. The minimum to maximum value, what we mentioned.
So minimum value automatically will be 0. Minimum value automatically.
Automatically initial value is 0. Okay. So now we have the option of now this is called as the flash values. So we are able to using the different kind of inputs here. One is the direct signal values, one more is the RC signal values. So the RC stands for rolling counter. We can call it as the rolling counter signal values. That is, we are having some limits. We are able to edit the limits also. So 0 to 100, 0 to maximum, 0 to 200. What are the values we enrolled? The values will be rolling it according to the random ways. Not we are able to setting it. So that is the other input also. The third one is this panel column. So in this panel we are having some track code, some user input output values, and then we are having some switch values. Based on that also we are able to giving the values. So initially we are able to just flash the values, but this flash values is not sufficient for our testing purpose. This is one kind of values. Okay. So instead of that, you just right click on the signal. For example, you go to vehicle speed, right click on the signal, it is showing some options. So on that you just select the set to rolling counter signals. Set to rolling counter signal. Once you set means automatically the values will be you can see the values will be going for the maximum of database value and then come to minimum of the database value. The same values you can see in our IC also. You can see here IC.
So here we need to change the right.
You can see here this IC also the values will be changing. So what are the values changing in the PC node? The same thing we will see in our IC node also. Okay. So the receiver rate is properly receiving. Okay. So and then one more point I will explain there. So when we are working with RPs with the open source, at the time we will face some time delays also. Okay. So just please ignore that. Okay. So if you are facing any time delay, just turn off the simulation. Turn off this RP simulation again. You can turn it. It will be getting the problem. Okay.
So we said the rolling counter, so we will start from 0 to max. But what is the frequency? Plus 1 or plus 2
Subsets. The subsets it is taken as a random. So this IG block is taken as a random now. So we are having random options. Interactive embedded block, got random options there. We are not able to control. So instead of that, we are having the other option as a panel control. Okay. So the panel control we are able to control on it. So I just complete this RC now. So now the rolling counter is enlarged for up to maximum values. So we just right click on any signal. It is asking for edit RC limits. One option is there. So before you need to go for RC limits, you just set the signal as an RC counter. Okay, it means rolling counter. Afterwards, you go for the edit RC limit, means you will get the window like that. So in this window, whatever signals you enrolled as RC, it is showing everything. So as of now, we just enroll only vehicle speed. Vehicle speed is RC signal. For example, I can mention transmission gear ratio also. RC counter means RC signal. Now we will just go to RC limit. It is showing that two signals also. Okay, so what are signals are in that RC signal? So that is limits we can see here. I just explained with the now the limits are active, the limits are enabled, but we are going to do some limit ranges. So it is RC enabled, which means RC signal enabled means default value is 0 to maximum, or else minimum to maximum. Okay, so I just enroll this limit. I can set it is the lower limit as 0, upper limit as 10 minutes, and then give OK. So now the values will be decreased up to 10 only. So you can see here. So up to 10 only the values will be increased. So the limit we can set here for the RC counter. Yes. So first we need to set the normal. So just you can see these are normal signals. The signal mentioned means it is called as a normal signal. So right click on the signal, you are having some option set to rolling counter. So you just set it as a rolling counter. For example, what are signals you go enroll to, we need to enroll it. You just right click again, we are having the one option is edit RC limits. Edit RC limits, you just open that. So here it is showing which signals are having that RC. So already it is enabled for that default value 0 to maximum. So for our requirement we need to give some values means. So I can give the vehicles prices 0 to 10 means it is going to the limit of up to 10. Okay, so that whenever I enable this, it is working. So just give OK. So now it is going up to 10. But we are seeing like it is a decimal values. So here it is not working for decimal values, it is working like a factor values. So it is taken as a factor. So that example I mentioned transmission gear ratio here. So I just go for RC limits, edit RC limits. So here also I mentioned 0 to, for example, I can mention 100. Okay, I just use enter and then start the limit time. So as of knowledge, so once we enter this limit means we need to get 0 to 100 only. Okay, so 0 to 100 only we need, but it is showing 0 to 246 something range is also it is going. So it means it's crossed our limit. Correct? So how it is working means it is mentioned for the factors. For example, right click. It is called as the maximum value is called as the maximum factor limits. So how many steps we mentioned? For example, it is mentioned about up to 100 steps. So in this transmission gear ratio, we have having the factor value of 2.57. I just open the database. So this messages and the TCU. So this vehicle speed. So you can see here the vehicle speed having the factor value of 1. So if we are giving the value from 0 to 10 means it is given as a 1, 2, 3, 4 up to 10. But in this transmission gear ratio, the factor value is 2.57. Okay, so 2.50 means we mentioned 0 to 100, which means 100 times it is included as a 2.50, 2.50, 2.50. So final output is a 2570, which means 257.0, like that. Okay, so that we are getting the values up to 257. Now you can see here it is the values up going up to 250 something, 250 something. You can see. So 254 like that. So it is the range of 257 up to 257 it is taken. So that initially I mentioned the RBC is fully working on the help of factors. Okay. So what are the factors we mentioned as a 1, 2, 3 means it is not an issue. Some of the point values only we will get some confusions. Okay. So the transmission gear ratio having some point values like 2.57 like that. So that it is going up to 250. But the factor value is 1 means getting it wrong.
That factor that we have created, no sir.
Huh?
While creating the messages, we have given the factors. The same factor value
Yes.
coming, right?
So whatever we have mentioned in the database, the same value only it will be taken. Okay.
But here, when we set no from limits from 0 to 10, but actually it is decrementing from 0, it is directly step on to 10, and it is decrementing at 10, 9, 8, 7, that it is coming.
No, it is not coming like that. It is taking only random values. It is not like a rising and falling values.
Here in this.
For you take.
Factor we are given, right?
Yes. So for example, for Philippines, so here I have mentioned for vehicle speed 0 to 10. Here the factor is a 1. So first order is a 1, second order is a 2, 3, 4 up to 10. But here the factor value is a 2.57. So first order is a 2.57, second order is a 4 point something. So next order is a plus 2.57 plus 2.57 like that. But the maximum reaches it is giving for only 100 times factors. So 100 into our factor value 2.57 means we will get a 257.0 something. So that here we are able to reach the random means also we are able to reach only up to 257. The values are taken as a randomly. It is not like any step size increment. It is taken as a random level. Okay. So again we don't want this RC means you just click the signal. You are having an option is called as a set to normal signal. Once you set to normal signal means again we are able to flash some values. Just right click here. You are having the option as a set to normal signal. Okay.
So the transmission gear ratio I kept 0 as a lower limit, upper limit is 100.
Okay.
But these beyond it is giving no results.
Three fixes.
So up to 257 you got it as well.
Up to
257. Yes. So that is what I explained. So in this database we have that signal value factor as a 2.57. So it is 100 times we are able to increase the values. We can give the rule to increase the values up to 100 times of the factor values. So 100 into 2.57 is 257. So it is taken the range for up to 257.
This one.
So here the manual work is very less. We are having only two options. One is a direct signal, one is a RC signal. Okay. So another one is a panel output, panel input or output. So afterwards we are going to work with only camel scripting. So using this vestibular simulation, we definitely need a scripting. So without scripting, we are not able to work in this vestibular simulation. Okay. So this is like on a tree we are having. So we don't have the ECU. So instead of the virtual ECU, we can take in this RB simulation. That is what we mentioned. So apart from this, everything we are writing by code only. Okay. So for the code, we need to follow some orders. Like first you can start the simulation. Second, you can write the code for the start the rest of the simulation. So third, you can write the code for the activate the network. So afterwards, you can write the fourth line for the activate the node. Fifth one, you can activate the message. Sixth one, afterward, you can get the what is the existing value. Based on that value, you can write it. So that is the camels only we are doing more work with the help of this RBS. Okay. So as of now, why I introduced this RBS means the panel also in the simulation column we are having an option is a panel. So the panel also will work by the help of RBS only. Secondly, only we can take to the transmission window. So in this transmission window will be work on secondary. So the first importance is the RBS only. So based on this RBS values only it will be work. Okay. So in this panel we are having two options, read and write options from the write options. Okay. So read means nothing but it will be read what are the values read properly. But read and write means this reading based on that value will be going to write it also. Okay. So I just explained. So as of now we are having some keys, which means this is for expand and this is for collapse, which means there's some shortcut keys. So this is for select all the modes and the messages, which means once you select this means all the modes and messages are activated in this trace window. We can see all the messages. Okay. So whatever messages the database current, everything will be run here. Okay. So next one is deselect the node only, node and the network. So it means the CAN database network. It is showing only CAN database. This is one for the deselect all the nodes and the messages. Okay. It is just like a shortcut key. So here you are able to save some configurations also. So configuration is nothing but the auto-start-RBS. So whenever you can open this automatically, whenever you can start the simulation, the RBS also will get the activation. So just to start this, automatically RBS also will get the start. Okay. So next one is so import configuration, export configuration. So what are the configuration we did here? For example, some of the signals you mentioned as the RC signal. So for that RCs we put some limiter. So that are the configurations we have exported here and imported to some other systems. So on the initial values, use the database initial values, use cost values all zeros, which means in this initially we have all the values as a 0. So we can mention you can take the database values, or else you can using the last values, or else using all as zeros like that. Configuration is nothing but the auto start RBS, send message and modification. Like so, what are the message modification? I will explain what are the modification. So the display RF signal and the display topology means that absolute time and results. Okay. So ignore RF message for HL node. HL node means nothing but real time mode, order the loop mode. So that is what I need to explain here. So now we are having here 26 ECUs, but we are not going to work with the NPL 26. So now 24 real time ECUs we are having, the 2 only we don't have. So that on the time purpose you just activate that 2 nodes only. You don't need to activate all the 26. You just activate only 2 nodes. So what are the values you need to transmit here? You can transmit using the scripting. So that is what it is mentioning. Ignore RX messages for achievement. So whenever we don't want these real-time mode values, we just ignore it. Or else we need it, you can just use the checkboxes disable. Okay. So select the MP means nothing but here mini program. So mini program means our capital scripting. Here they call as a keyword as a mini program. So MP stands for the mini program. C mini program, Python mini program like that. So here it will generate some code also. So select signal, so set to normal signal. So what the signals we have selected, we can mention normal signal, rolling counter. So one more is a checksum signal, but we are not working with checksum signal also. Okay. Okay. So these are the common settings and common configuration in the RBS. Okay. So here I mentioned that some message modification. So here also we are able to modify the message values. For example, so TC value every time we have mentioned as a 10 means we can mention here as a 100 also. So now the message will be transmitted 100 TC. So what we did in our transmission window, same thing we are able to do here. But when now we go add an attribute definition, gen message cycle in our database, after that only we are able to change the internal time. Okay. Okay. So what are the time levers that we for example conduct? I mentioned just a turn on this RBS, native network.
If you change the timing, so receive messages won't change. They different timing. Suppose now you go to ICP.
Yes.
ICP is still 10 only.
So we just activate the mode.
interval is not changing, the value is also equal to match.
Yes. Transmitted side only it is changing. So in the receiver end, we can check with any one of the panel communications. So on the time we will check. Yes, in the
It
panel.
has to be same, right?
Sir?
It has to be same. Receiver side and the sending side, the timing has to be same.
Yes.
So it's definitely different.
So what the timing we send here is the same timing and only we are able to receive also. Okay. So this is the time modification, which means message modifications. Okay. Okay, so this is the concept of CAN vestibular simulation. Shall we move for this panel? Or else do you have any doubts in this CAN or yes?
So capital scripting is in plan.
No. This CAN is a type of simulation, like doing some switches, track or these kind of things. The capital scripting we will write for later, which means yes. For example,
We go to CAN hardware simulation 3 times.
yes.
One is flash, that you explain. Second one is RC. Now third one is capital scripting.
There on this panel afterwards capital scripting. Okay, so which means why that capital scripting means for some of the transmission and receive messages. So for example, collection of messages. So gear shift values comes under ECU. Vehicle speed values comes under TCU. Engine speed comes under engine message. So collection of messages will be collected by this scripting. So we can take some temporary variables to store on that. According to the values, we can give some indications. So for example, so engine RPM speed is greater than 2000. Vehicle speed is greater than 20, but the gear shift is 1 means we need to show some overspeed. Or the RPM is overrated. Like that, we need to give some indication on instrumental test. So on that time, we are using some of that scripting. Okay. So shall we move to panel? You need to check on this RPS. Shall I move? Okay. So I just close this. Go to stop. Initially stop the application. And go to simulation. So this environment you are having that panel option. So in the environment you are having the panel option. You just click here, asking for add panel. So you just give add panel. So you will get the window like this. Okay. I just maximize this. Okay. So here we are having toolbox properties and then objects. So this first properties it is showing like it is a background color for this panel. For example, I can change this. So this is the height and width for that panel layout. So for example, like we can set as 600, width we can set as 800. So in this values, the one white line is there. So what are the simulations? What are the designs you have created? You just put it on this white lines only. You just scroll on this downwards also here. Okay. Okay. So we are having the panel designs places. Okay. So I can mention. So we got this much of places to create some unique clusters or any kind of simulations. Okay. So next one, toolbox. So in this toolbox, we are having the different kind of options like the read and write, system, and then view only. So these kind of options are there. Just to go to this toolbox, just to select this toolbox. Okay. Just to select the toolbox, you are having option read and write, and then system. So one more is that view only. Okay. So I just giving some intro about this read and write. So this read and write means nothing but it is able to some read values and then we are able to write some values. Both inputs and then outputs we are able to giving this using this kind of codes. So this system is nothing but it is using this button to start the simulation also in this panel. Okay. So next one view only means nothing but we are able to just receive the values. We are not able to trigger any values from this side. Okay. For example, LED will not trigger any values, graphics will not trigger any values, cages will not trigger any values. Like progress bar, chart, and text, it is not able to trigger any values. But instead of that, in this read and write, you can see the button will be able to trigger some values, checkbox giving some values, file selectors, image buttons, path buttons, scroll bars, these kind of things giving some values. So I will just giving some explain. So I will just explain this using we will start with switch. Like you just double click this switch means you will get the switch here. Okay. Just double click this means you will get it. After the properties of the switch also we will see here. Okay. The properties of the switch also see here. So in this object is nothing but what are the tools you have added, it will be shown here. This object problem. Okay. So you have three options: toolbox, properties, and then objects. So the toolbox is for what are the few features we have in this panel, we can see here. So the properties, what are the tools you have selected, that kind of properties we can see here. So this objects, what are the tools you have added here. So it is going to give some issue. So in this, first you will just double click means it is asking for signal type, can signal, in signal, or let's say API or anything. Okay. So you just give the can signal and then click selection. So it is asking for we can generate the RBs only. So like that. Okay. So after it is opening for the database. So which signal you are going to enroll here? For example, I can mention the log. You can try check the log. This node initially we need to check before going to mapping. You need to check here. I can type the log after it is opening from the RK node TX message. After RK message, some signal I can select it. Okay. So log means here it is showing some system address. So 0 means nothing but the first ID of CAN channel. So CAN channel 1 from CAN DBC network from RK node, RK message log signal I am going to map here. So they properly we need to map on it. So some of the people, for example,
So log itself so many messages are. You just click on log, which is log. So downside so many logs are.
so this is nothing but it is showing from RK ECU now. So it is just giving some filters only for TX message. So the next for RS it is next showing both TX and then RX message. Next showing TX signal only and next showing TX and RX message. Any log. From this node you can select any node. From RK node you can select any node. Before the BCM these are all full from same signal. So they are giving just some individual definition. Only TX message, next RX message, next both the combination of TX and RX. Next TX signal, next TX and the RX combinations.
In BC, downside BCM also what is there?
Yes, but we are not going to work with this because this is a receiver. Okay, so we are just going to trigger the value. So trigger means that is a transmitter side. Okay, got it? So once you select it means, for example, if you are selecting anything, means you are getting the address. So from this node, first I selected this log, the address are same. So I select this log means also the address is same, which means CAN DBC, RK node, RK message, some signal. Okay. Okay, apply. So now this switch value planning that going to trigger the signal value of log. Okay, from the transmitter node of RK. So I just track here. So here you can see the options. It is asking for some top, so bottom left you can see here. Once you select the switch in the bottom left you can see here. It is value of value left, value right. So what are the values we have triggered? For example, if you are working with vehicle speed means whenever you press the switch right side means you can mention the value as 100. So this left side means the value is 0 or 20. So what are the flash values immediately we need to use it on the time using. For log we are having only the two values 0 and 1, so I mentioned it. So it is asking for next one variable link. So based on our selection of signal, so it will be showing. So we are selecting the CAN signal means it is can signal and what the signals you have selected. So the point mentioned here. So next one variable type is showing PST can signal. So nothing but so post can signal. We are going to mention the type of post can signal. Okay. So this with this height are nothing but the height of this. So based on that, this with the height only will be changed. Okay. Okay. So now we can take one receive. So we just using the read and write here. So now switch using the same thing. We are going to the BCM. We are receiving the same log signal, correct? So for that I am using the LED. Okay. So you just scroll down. You only option we are having here. LED is there, correct? You just scroll down on toolbox here. We are having option view only. And then listed as a 2, 4, 6, 7 one is a LED. You just double click this. Again the LED will be shown here. The same concept. Again you can double click. It is asking for which type of signal you are mapping. You can say can signal and then click OK. So then it is directly taken to our database. Here also I can select log. Log. So from this you don't need to select from RK receive. You are going to select whether receive from this body control model. Yes. So here the receiver it is showing like log. Now you can see address of first channel can be PC from PCM, but I received the RK message from the log signal. Okay. Got it?
They also will have two RX message.
You can select anything from BCM node. You can select anything from your select this or this anyone, but you can select from this node only. The node is important here. So this is what the real time transmission received from one node to another node. And click OK. Okay. So it is asking for turn on color means green color. So turn off means that one. So turn on values we are mentioning value 1 means value 1. So in this top bottom left you are having that value on and off. Okay, so now we are mapped. Just you start the simulation. In this analysis, start the main simulation. So once you started means, now we are going and check for the simulation can RBC. Okay. So just to go to that RK node already activated. So the RK node initially activated. RK node alarm activated here. We just hold on this. I will go to this one. And I just turn on the values.
So they are not activated automatically.
Automatically activated because that is the intercommunication between panel to CAN testicle simulation. So initially you added one signal, it is asking for the R-based communication. So that is what we mentioned. So if you are not turned on means also it is automatically taken to the R-based communication. So that is what they are giving that pop-up box warning for us. Okay. So now you are turned on the log signal. You got the output in this PCM. So now it is acting like this switch is a RK node. This LED is a BCM node. Okay. Let's go to trace. In this trace, you are not find anything. Correct. So that is also important.
RBS.
Go to RBS and just you turn on this network. Turn on the RBS simulation. But now it is intercommunicated. The values are changed. So the easy communication is changing, but we are not getting the trace value. So that I mentioned turn on the RBS simulation. Okay. So now you can see here the RK value is something we can mention. If I mention log here, so if I mention the switch on means that trace window we are getting the value of 1. Okay. So now I turn off this. The value will be 0. So as I turn on this, the value will be 1 and our trace goes. Got it? Okay, so now that RKE node, this RKE node only transmitting this receiver body control module. So for the body, we are having the transmission data. So this data you will see is a TX condition. So for the TX we can directly communicate with the panel communication. So I just now explained to only switch up the LED. So instead of that we are having more values in the process or track or selector input output that are we will discuss. Okay. So now you understand the concept of this panel. So how it is intercommunicated with the RBS also. That is the main point. So here that transmission and receiver is one kind of common concept. But how it is interacted with the panel to RBS communication. This residual simulation communication. Okay. So that initially I have mentioned what are the values you need. Initially you need to go with the start simulation. Afterwards, RBS start simulation only we are able to capture any values. Okay. So once you have connected this this is your read rate. This is only read only, which means view only. Okay. So once you can enable the read rate in this panel means automatically our residual simulation mode will be activated and then the network will be activated. But we need to manually turn on the RBS. Okay. Got my point? So you are working with read and write functions in our panel communication. You no need to turn on any node, any message, any network. But we need to turn on the residual simulation. Okay. Okay. So for the environment they are mostly using for MIL discipline they are using. So in this software development we are using host PC with compiler code, which means no hardware like our PS master tool, virtual devices, these kind of things enough for SIL. For the hardware development we need a real-time simulator and then physical hardware. DLT means device under test, like our hardware easy.
Real-time simulator is different one.
Huh?
Real-time simulator is different with the test manager.
No. So what we use for software in the loop is same thing they are mentioning here real-time simulator. So like PS master here act as a real-time simulator also, but it is getting the values of device under test like real-time ECUs. So these are the hardware used. There is no need of any hardware for this two types. But here we have any ECUs connected input output system. So accuracy levels of this hardware in the loop MIL and then SIL. So cost efficient and then stages in early design phase and then mid development and then last stage of validation with the HL. So this is the difference between the major difference between the MIL, SIL, and HL.
So 3 phases are mandatory for in company.
Yes, in company mandatory. Yes, but we are just focusing on SIL. So afterwards we are just focusing on HL because they are just working with some of the coding knowledge. After they are going to use the real-time knowledge.
But here in SAM, we are creating the panels, we are creating the instrumentation cluster, virtual.
Yes.
But the MIL also will do the same. But
Yes.
only platform is different.
Our platform is different. But in the same way, we will work like that some x-axis, y-axis, this kind of the we will really work with the real-time steering, the real-time accelerator. So that are the models we are able to create here in this MIL. Okay.
So that steering part we cannot do in the SAM.
No. So instead of that, we just generate the values. So instead of steering wheel values or steering angle values, we can.
So is there any link between MIL and SAM?
Possible. So we can in this tool we are having this case master. I think MATLAB. Yes, here you can see MATLAB automation. MATLAB automation, Canary automation. So these kind of automations we are having. So once we did some programming or did some simulations using the MATLAB, afterwards we can implement the
Import that
SIL and the MIL. So this tool have more features. So here autos are also coming. So autos are setting up. So ECU architecture they are called as autos. Okay. So these kind of different kind of protocol, different kind of features we can add in this case. Okay. Shall we move to the topic? Yes. So now we understood the concept of panel. So this panel will be able to transmit some values, able to receive it by the type of RBS only. Correct. So instead of this read and write, now we are just only with view only. View only means it can receive values from any side. So I just delete this switch. Instead we have so that we have to select. So initially I can check this turn off. Okay, we can deselect everything. So instead of that, we have to generate the values from transmission window. Okay. So add transmit. Open the transmit window and then right click, same concept, and new message from database. So here you can select RKE. So RKE. Okay. So afterwards we just giving that value as a total. Yes. Apply and then I just start the simulation and just start the values. Here you can see the LED will be blinking based on that indicators values. Sorry, it means transmission control unit indicators values. So now this is no need of any R-based communication, R-based intercommunication, because it is just a view only concept. It is just like an output source window. So now you are working with any toolbox in the view only option. No need of intercommunication with the R-based.
So how can I delete the long button in the simulation?
You just click the one and then using the delete key. You just click the switch and using the delete key in our keyboard. Or else you just right click, you have the option of delete. So afterwards, instead of that switch, you can just using the transmit window. So in this transmit window, you are able to transmit some values, you are able to receive. So before that, you can just check can always is turned off or not. I think sir, you enable the auto start RBC. Yes. So now it is working like a real-time ECU values. We will get it from the real-time hardware. So you can just assume that this transmission window is a real-time hardware. Okay. So RBS is a rest-of-the separation, which means without ECU. So initially we worked with the transmit window everything. So now I just give the difference between that. So now we are all working with transmit window means you are getting the value from real-time hardware. So suppose you are working with RBS means you are just simulating the values. So that is the difference between a normal transmit window and then that RBS window. So instead of that, I stop here. I mapping this log. So now we are going to transmit by the real-time hardware. You just select the peak window and then you give the value of 1 here means the LED will be turned on. Okay. So now my work I have two options. One is we are going to generate with hardware, or else you fully understand the concept of panel, like you have created some design, afterwards we will do that. Which one we can select?
Your choice.
Okay.
Flow you.
Okay. So first we can understand the concept of panels. Some tools also we are having. I just explained only LED. You just checking the different kind of tools also. Okay. Stop the analysis. Go to this tool. So toolbox you are having different kind of options like button, checkbox, file selector, image button. So you just ignore the file selector. Now it is no need, which means we need to copy the directory and this kind of things. So and then remaining things, the memo also no needed, but you want means you can add it. So now your work is you have done this settings option. One option is there, open help document. So in this left we are having settings symbol. This means the second bottom you can open help document. So this help document is explain about this all kind of features. So what is the file selector, what is the image button and everything, it is explained here. How to access like that.
In objects we have where click button we can go to.
So just to go to this settings option in panel. So wherever you open this help document, that particular topic will be open. So else if you go to software management, it is showing entire software management. Okay. So using this help document, you just open this all kind of things. For example, I explained in the image button. Okay. For example, I will explain the image button. Afterwards, you will check for these all things. I will give this center there. Or else after afternoon you will take it. Okay. You don't need to design anything. You just open this kind of tools and then you can generate some values. It is working or not. I will just explain the image button. So now it is showing the image button. So image button means nothing but using the image you can generate the values. For example, the value of 1 means the value will 1 be generated. The value of 2 means 2 be generated like that. So how we can say means here we are having the image count. How many images we are going to add for this button. For example, I can mention like 3 images. Okay. After putting an index, it is asking for the index. After putting the count, the second one it is having the index. Okay, it is having the index. So first image you need to upload it means the index value will be 0. Okay. So afterwards you just select the second one. So which means on the image options. You just double click means you will get the drop box like that. You just open load. Okay. Load means what are the images you got downloaded. For example. Okay. So you just download 3 images, any 3 images. I just open this loader. Also I am going to upload this one. For first images are 1. So now okay, so image 1 will be uploaded. Secondly, you change the index. So index value is 1. 1 means again the image gone. So again go to the same image column, double click. It is asking for load. You can select the image 2. Yes. Okay. So next image index 2. So again clicking the same, you can upload the third image.
So in one box we can upload 3 images. In only one box we can upload 3 images.
Yes, in one box we can upload the 3 images. So now we upload the images. Afterwards we are going to view the values. For example, now we can select the index as 0 means. So it is asking for the value as 0. So what when this bottom on that you are getting value option. So I selected the index as 0, the value will be 0. So as per our recommend we can change anything. So index 1 I can view. So what are the values we enter here? Don't forget to press the enter key or the value not be saved or not changed. So index 1 value 1. So index 2. So the value 2. So here the values 2, 1, 2, 3 is required for us. Or if you want any 100, 200 means based on the signal you can add it. So afterwards we need to add signal for that. Which signal we are going to add here. So that as per the same concept you just double click here means it is asking for CAN signal. Give the CAN signal. I can give select. And going to add a gear shift. Gear shift. So the values it is going to be generated so that I am selected from the transmitter easily. So TCU of gear shift status. So first channel CAN DBC TCU node TCU message gear shift. Okay. We just give this and now we can start the simulation. Parallelly we are opening this. So now you can see automatically the TCU messages are running now. So the TCU messages are automatically running here. How it means that this is the read and write. So that is what I previously mentioned. If you are only work with view only means it is not associated with our RBS. But if you are working with read and write tools means it is directly taken to the connection of RBS. Okay. So now the value you can change it. If I press the again, the value will be changed here as a 1. So again I change the image. The value will be changed as a like that. Okay. So it is the image button option of for example gear values. So you can press this button 1 means the value will be 1. Press this button 2 means the value will be 2. Press this button 3 means the value will be 3. So again you can press it means the value will be changed. Okay. So now I just uploaded only for 3 values. Once again I will explain. Stop the simulation. So we just added the image button here. So after adding the image button, you are having how many images you need to add for the particular button. So for example, I have mentioned only 3. So that the image count I can take as a 3. But the values will be taken as a 0, 1, 2, which means the index value only can be taken. Image upload. So I can start with the 0 as a 0, and then 1 as a 1, 2 as a 2, like that you can add it. So go to this image column. You just double click means it is open the file directory. So you just go to load where you have that file. You just select it. Open it means that will be open and then click OK for that particular image. Okay. So after that we just start the TCU. So we can start the simulation and then go for Trace means automatically the message will be running here. Okay. So based on your, so initially we said for this image 1 as the value is 0. So I can change the value to means once you click it means the value will be printed, the value will be 1. Again I click it, the value will be 3, the value 2 will be printed. Okay. So these kind of the features we are having different kind of tools, this read and write and then view only. Okay. So here I am just explaining the only image button. So instead of that you are having checkbox, buttons, input output box, path button. So what is that? Everything they have mentioned in that to help government. So what is the definition of checkbox? What is the definition of button? So what is the definition of path button? They mentioned the help government. Okay. So if you are working only with this view only means no need of the connection of any RBs. Okay. So for my requirement is you can create 2 panels. One panel is only for view only. So another panel is only for read and write. So that you just go to simulation, you are already having the panel session, correct? So already I have only one panel. So again what I am saying, you can add one more panel. Okay? So add one more panel. So in this panel you have add all this kind of like what is that view only. Which means this LED, image, blue box, graphic, these kind of things you can add here. So the previous one, it is taken there for only read and write. So you can using your buttons, everything. For example, you can mention. So this window is for read and write. So in this read and write, I have to add using the same button. Switch can signal. And then add some signal. So what are the transmitter signals you can add for read and write? So what are the only receiving signal you can add using the help of view only. So for example, I can check for log. So log is transmitted by RK node, so that I have added here. So you just hold up this. So and then open another tab. So in this tab you have just added the view only options. You are having view only options. So here I am adding the LED. So in this LED, we just add the receiver side. Can signal. The log is received by the body control module. So here I can add the log. So now you just start the simulation. Here you can see TCU and then RK. So the RK is counting based on our switch values. So that okay. So whenever you have turned on the values, so this window, this panel you have turned on for the log value, so this window you will get the output. So here if you have turn off means this window will be going to turn off. So one panel is going to acting as a R-based transmitter, one window going to act as a R-based receiver window. So it is a, these are the collection of PCs from this panel for transmitter. This is the collection of PCs value further from the R-based receiver side. We can check this. No, it takes JPEG. Sorry. JPEG file only. Only JPEG file only. Shall we check this? So now you got the understand the knowledge of this read and write view only means we can go to the some designing purpose. Taking the panel simulations to giving some inputs and read some outputs also. So instead of that, if in the output source, for example, so this panel is looking like the output source. So in the input we need to take on the real-time power means we need to connect with our kit with the peak USB. Okay. So for that we can just open Arduino. So Arduino we are having others just search Arduino. So the app is there. We just open it.
Arduino software.
Yes, you need to use it.
Yeah, just it is open source.
Is the open source?
Open source only.
No, we have answer.
Okay, so in that, go to file, examples. So on this one, the custom libraries will install like auto WP MCP2 from. Go to top of the file. So afterwards open the examples. So in this bottom you have the custom libraries as a auto.
So you people are installing everything.
Yeah.
This library.
Yes, we need to install it, or else if you not install it, just to go to this libraries, which means in this top of we are having some icons. Go to libraries. So in this library manager, just type auto WP. Auto WP. So the library function will be shown here. If it is not installed, click here install. If it is installed, means nothing, not issue. Okay. Auto WP. So the library is called as a Auto WP MCP2515. So Auto WP -MCP2515. So we need to install this library for our CAN programming. So here we are working with the CAN module of MCP2515. For the CAN communication of MCP2515, we are using this library. Okay. So suppose if you are downloading new Arduino IDE in your laptops or in your own PCs, means you just go to this library manager, just search for Auto WP. You will get the Auto WP MCP2515. Just give the installments, automatically it will be installed. Okay. So again, just to go to File, Examples, open the Auto MCP2515. So here we have the 3 types of programming: CAN read, CAN write, and then CAN speed test. So we are going to write the program, CAN write program. Read is for receiving the messages, write is for transmitting the messages. Okay. So here the receiving end we are going to set as a TS master, and the transmitting end we are going to set as a write. Okay. So that we are going to open the CAN write program. Just click it, it is automatically open. So once it is opened, it is showing like 50 lines of code. Okay. So I will explain the step by step what I mentioned there. So first line the hash input of SPI.h. Like C programming we using hash input stdio, which means standard input output dot well, same method we are using SPI.h. SPI means nothing but serial peripheral interface. Serial peripheral interface header file we included. So second line here is the MCP2515.h. So this is the header file for CAN module communication. So we are having the real-time module of MCP2515. So for that we are creating some inbuilt functions. Okay.
That is a microcontroller.
Yes. Yes.
Using a CAN filter.
Yes, sir. This is a code for CAN controller. So now Git having the CAN MCP2515. Yes.
MCP25.
Yes.
Finish.
Okay. So next time they are mentioning structure of CAN frame, CAN message, structure of CAN frame, CAN message. So this is nothing but they are creating on structures. So for example, the employees are creating on structures for getting the employee code, getting the employee salary, getting the employee contact number. Same concept they are using. That variable name is called as the instead of employee they are using CAN frame. So what are the structures they have means CAN message ID, CAN message DLC, CAN message data, which means if you are working with ADLs means byte 1, byte 2, byte 3 that values. Okay. So for that, why they are mentioning two structures means they are going to transmit two messages. So that will automate message 1, message 2. For example, employee 1, employee 2, we create same like that message 1, message 2. So sixth line is the MCP and then MCP of 2515 10. So this 10 mentioned as a chip select of our Arduino kit. So for example, now we are working with the Arduino Uno means mostly you are selecting the chip select as a 10. So Arduino Mega 2560 this kind of thing, this chip select as a 53, pin number 53. Okay. So based on our pin configuration. So in our lab for Uno we selected the chip select of 10 and then Mega for 53.
That is the pin number.
Yes, pin number. So for if you are having an Arduino board, in the other places you have it. You just check that we have one CS option. So the CS called as a chip select. Okay, just to look here this MCP module. This MCP module, you can see there some wirings are there, wiring communications. So first one int, second one SCK. So third one slave in, fourth one slave out, fifth one CS is there. Correct? So it is MCP module. Or let's homework kit, Arduino kit.
download இருக்கு இங்க ஒரு கிட் இருக்கு அங்க ஒரு கிட்
So sir, or else you can take that one.
Sir, it's connected.
No, just for reference. Or else just give it the kit.
No, it's all connected.
This is also connected, sir.
Sir, మీరు ఒక హ్యాండ్ sir ఒక హ్యాండ్ తీసి.
No, sorry, sir.
Ashok sir, you take that.
Okay. So from this MCP module, we are having that communications of int, SCK, slave in, slave out, chip selector, ground, VCC. So in that chip select pin, we are connected the Arduino as a pin number 10. So directly come to that Arduino, you know. So in this lecture, you are having the values of RTX, RX, 1, 2, 3, 4, 5, 6 up to 10 is there now. So on that we can mention the chip select as a 10. So that coding I mentioned here as this, see the coding 6th line. So I have mentioned MCP25 as a chip select of 10. Okay. So in Arduino Mego we have connected the chip select of 53. So Arduino having more number of pins. Okay. Sorry, in Mego we are having more number of pins. So that we are using the MCP25 chip select as a 10 and then 53. So this is the concept. Okay. So definitely we need to mention the pin number here. Chip select pin number we need to mention here. Now we are going to compile for Arduino Uno board means you can take as a 10 only. But in our big size we are having Arduino Mega also.
You can use any other pin also. You can use.
Yes, what are the pins you have selected? But the default range they mention in chip select means Arduino Uno is taken as a 10, Mega is 53.
So
It is a standardized board.
any digital or analog pins that we have to select. You said with 10 is one number that we are taking.
Yes.
So generally you have 6 analog and 15 digital. So any of that I can say or only specified is the things we have to select.
No, any of the values you can take it. The chip select you can take any of them. But standardized they mention 10.
No, we can connect it to analog pins also.
Not analog. So in this lecture,
digital pin only we can able to connect sir
in this lecture pin from values of 1 to 10 or 12. Okay. So on that we can connect any values. Okay. Okay. So this is the basic getter files, the basic pin numbers we have selected here. So next time you can see the void setup. So here you have two options. One is the void setup function. Second one is void loop function. So you need to check this here. So from the line number 9 we have the void setup. Line number 43 we are having the void loop. So what's the difference between this void setup and void loop means? The setup function code will be run only one time whenever we are dumping the code. The loop will run so many times. So that is the difference in setup. Setup will run only one time, but loop will not like that. It will be run so continuously, which means infinite loop like that dimension. Okay. So whatever code you go write in between that void setup column, that will be executed only one time. So, but in this void loop not like that. It will be getting the data continuously. It will not stop it. That is the difference between void loop and void setup.
Sir, I have a question.
Yes.
So we have given like wide setup. Up to MCP2515 is 10 means connected, so we have declared it, right? Wide setup we have to give all these data 0, data 1, data 7, all these others. How do we have given?
Yeah, I will explain. Just as of now, I just confirm 9 okay. So I will just give the difference between void setup and then void loop. So whatever code now we are going to write here. So if you mention any values, any statement, means it will execute only one time. In void loop not like that, it will be executed continuously. Okay. So I will explain this. What is this CAN message ID, DLC, everything. So here you have mentioned the structured CAN frame of CAN message, correct? In top fourth line you mentioned the structure CAN frame of CAN message 1. So the structure CAN that ID DLC, so which means CAN message ID, CAN message DLC, and then CAN message data. So that is what here we mentioned there. So ID number, what are the ID we need to transmit like For example, we need to transmit the ID number of RKE. We can check it in our case master. And this is. So for the RKE ID number is a 120. So now we are going to transmit the ID number 120 here. So instead of that, I can write 0x120. So now the value of DLC is 3 because it's carrying only 3 values, lock, unlock, tailgate. So in our layout, I just open the layout. So layout of our case, first bit is lock, second bit is first bit is lock, second bit is unlock, third bit is tailgate. So we can mention like that. So in our Arduino program, we can directly mention. So this is for lock. So this is for unlock. This is for tailgate. Okay. So now the 3 DLC is enough. No need of this remaining. So that I can delete this. So remaining the 3, 4, 5, 6, 7 I can delete this. So it starts with the index values only. It is an array now. So 8 DLC means start with the 0, 1, 2. So it means first DLC, second DLC, third DLC. Okay. So now understood that the CAN message, the CAN ID, CAN DLC dot data. So it is a common enough structure of CAN frame. Okay. So whenever we can access the CAN frame, we can use this like that. So if we are transmitting one more ID, for example, we can transmit vehicle speed. So vehicle speed ID number is 0x20. 0x20 it is having like 5 DLC, 8 DLC. TCU having nearly 5 DLC. So TCU having 5 DLC. So that in the program I have to mention 5 DLC. So 5 means remaining 3 no. Okay. So instead of that, so what are the values? So now the data of 0. So here lock means the value is 0 or 1. Okay. For example, I can give here 1. So unlock this is 0. Tailgate as a 1. Okay. So this value only going to transmitting from real-time Arduino. The same real-time ECU of Arduino. The same value we are going to receive in TS master. This is our concept. Okay. So I just explained only one message here. I just remove the remaining. Here also I remove the CAN message too. Okay. So now this while not serial, which means this is nothing but infinite loop. This line is no need. Without this line also we are able to execute this. Okay. While serial I just remove, not serial. Okay. So the serial that begin 115.200, it's a baud rate of serial monitor. So what are the inputs we are given? We can change the serial monitor output also. So for that we can set in the baud rate. So here we can set 9600 also or 152.00 also. So next one we are just inbuilt the functions of MCP255.reset function. Next set bit rate as a CAN and then next set an ARM mode. So that set dot reset mode is for what all the codes we have previously completed with the MCP25, it will be reset. Okay, that is called the reset function. Second end set bit rate. So the set bit rate is called as a CAN baud rate. So we are having a CAN baud rate of up to 1 MB per second, which means speed of the CAN. It will be mentioned as up to 1 MB per second. So in the DS master, we are having the default configuration of 500 kbps. So that here I am checking with 500 kbps. Okay. So initially they mentioned the low speed of 125 kbps. Instead of that, we just change the 500 kbps because what are the baud rate the ECU transmitting, the same one we are able to execute with the receiver, like means tester side also. Okay. So after 500 kbps using comma and then using capital MCP underscore 8 MHz. So this is why I am encoding means this is the oscillator frequency values. So the oscillator frequency values from our MCP and then to our tester cell. Okay. So that is what I mentioned MCP underscore 8 MHz. Okay. So next line is the MCP2 we set normal mode. So next set normal mode means the MCP is going to sending them it's a normal mode. So another one we have set loop mode. So the loop mode is working for the byte carrying the different kind of signal, which means the single byte we are carrying the lock, unlock, tailgate means we need to access them individual bits. First bit, second bit, third bit of the first data bit. Some of the places we are using a loop mode, but here no need of any loop mode. We are just like the main DLC. First DLC means one signal, second DLC means another signal. So we can go with the set normal mode. So then the serial and printer means nothing but it is like a printf statement in our C programming. So instead of printf, we are using a serial and println. So it is like the can, which means we did some configurations. So now the program is ready to write the can like that it is mentioned. So if we need means you can add it or if you just do it. Okay. So now next comes to the void loop. So whatever we have write, we just using the mcp215 dot send the message of can1 and then can2. But here you are just to send only one message. Okay. So mcp215 dot send message means now the coding is ready to send the whatever messages you have wrote. Okay. So after delay 100 means nothing but 100 milliseconds. The delay mentioned as a 100 milliseconds. 100 milliseconds once this code will be executed again and again. Okay. So the serial and println is for our confirmation. It is showing up the serial number confirmations. Okay. Yeah. So this is the code. Now we are going to upload the code in our Arduino kit. Okay. So before that, you go just put the port and select the board, and then need to select the EN also. For example, so before connecting this USB, okay, just open this select board. Okay. So initially it's showing some port. I think for me 3, 6, 7 is showing that. For you also some showing some inbuilt boards. Okay.
No
Because
problem.
మీరు ఇప్పుడు ఇన్స్టాల్ చేసుకున్నారు అదేం చూపించారు డిఫాల్ట్ అయితే మనకి బోర్డ్కి ఏదైతే కనెక్ట్ చేస్తే
So after we connect this, we will get which port we are connected. So now I connect this, I am getting the port number 5, COM5. Got my point? Yes, and then click the board. It is asking the what type of board you need to select. You just search UNO. UNO, that third one Arduino UNO you can select. Don't select any R4, Wi-Fi, MD. Just select Arduino UNO. So in here you can select COM5 serial port USB. Okay. So now we have to select the board as the UNO. Arduino UNO you can select it and then click OK. So now we are having the options as the compile. So click compile, which means verify. So after that, click the upload. The CR mark is called as the upload code. So now the done uploading we got it means now the code is uploaded in our ECU. Okay. So in the top right you have an option serial monitor. Top right you have an option serial monitor. Or the shortcut is Control Shift M. Control Shift M means you will get the serial monitor. Okay. Generating values from our real-time ECUs. Okay. So now we are going to this TS master. Open the family. Open the TS master. Okay. So whatever you did not an issue. You just open the TS master. Previously you did any project and also not an issue. Okay. Go for this hardware. So in this vendor selection you can select the peak also. So for you
also select the compulsory also.
Compulsory because we have so now we are going to use the white color test.
This is peak.
Or else we can do one thing. So without TS master you want to do means we have that one more option. So now
we will see this software.
Sir,
First we will see this software. Later we will see.
okay. Okay. So go to this vendor selection. So you can select the peak system. Okay. You can select the peak system. So for you don't want. Okay. For you don't want because you don't have any peak communication.
That kit no.
So it is only for this kit.
So if these don't have it, what has to be, he is not able to communicate.
He is not able to communicate with TS system.
Or he is not able to communicate.
Yes, yes.
It should be there to communicate.
This one. this is the peak device CAN interface. Okay. So from our hardware to our software tool, it is only transmitting the data. So for that, in Arduino, we need to connect with this CAN and then CAN load. Arduino with the MCP2 So now this kit having only MCP2 and then Arduino. So now we suppose this one is connected with this CAN load means. Yeah, we can connect. So from you both are there, so any of the system you can take the peak. So you both any of them take the peak. Okay. So just select the peak and then click OK. So go to this channel selection. Go to the channel selection, select our peak. So this channel one you can select the peak. So I don't have a peak right now. Okay. So you can the peak USB is there. Correct?
Peak channel 82.
Yes, it is showing.
Peak is showing us a
CAN channel 82.
yes, 82. That you can select it. So I don't have it, I don't connect the peak. So after connected that, you can click OK. So and then go to this analysis and then start the simulation. Afterwards open the trace window.
Yeah, open the trace.
After open the trace window, you are using the ID number 120. No? Open TS master once you transmitted after going to this TS master. Open the simulation. Open simulation. So if you are having any panel, means just open any one of the panel. Okay, I will give add new panel. Simulation panel, add new panel. You can open one LED. Stop the simulation first. So now the toolbox are showing here. You just scroll down and then click LED. So you can add an LED. Okay. So afterwards, double click. It is asking for the CAN signal. You can add CAN signal, and then so select the message signal as a log from receiver side. So the log is received by body control module. So this is what I mentioned. So it is not an RK. It is received by the body control module. So once you can select this first channel CAN DVC body control module received by RK message. So now transmitter is our hardware, real-time hardware. So receiver is our E0. Okay? Got it? Okay? So once you upload this, which means once you can apply this, turn on the simulation. Turn on the simulation. Now you can generate the value from real-time hardware. Now you can generate the value from real-time hardware, which means our Arduino. So now the value is 1. Now you are going to pick this instrument.